Good morning, students. Today we will be doing additional problems on DTFT. First problem. Show that DTFT of a real and even signal is real valued. Real valued means purely real. Show that DTFT of a real and odd signal is imaginary valued. Imaginary valued means purely imaginary. Solution. I'll write note. First one. If x of n has DTFT x of e power j omega, then x of minus n will have a DTFT x of e power minus j omega. If you replace n by minus n in x of e power j omega, omega gets replaced by minus omega. Second one, if x of n is a real sequence, then x of e power minus j omega is equal to x conjugate of e power j omega. Third one, x e of minus n is equal to x e of n, because x e of n is an even signal, and x o of minus n is equal to minus of x o of n, because x o of n is an odd signal. These three concepts will be used for proving these two conditions. Now, actual solution I will start. X of n be an arbitrary signal having even part x e of n and odd part x o of n. Let the DTFT of this signal be a complex function given by x of e power j omega equals a into a function of e power j omega plus j times b a function of e power j omega. So x of n is a real signal, but DTFT is complex, having real part and imaginary part. I will replace n by minus n. X of minus n equals x e of minus n is same as x e of n. X o of n is same as minus of x o of n. We'll have a DTFT. Reflection in time corresponds to reflection in frequency. X of e power minus j omega. X of minus n. I'll write it once again. I'll replace n by minus n. That gives x of minus n equals x e of minus n is what? X e of n. X o of minus n is what? Minus of x o of n. Will have a DTFT. If we replace n by minus n, omega will get replaced by minus omega. X of e power minus j omega. Since x of n is a real sequence, x of e power minus j omega equals x conjugate of e power j omega. Hence, x of minus n equal to x e of n minus of x o of n will have a discrete time Fourier transform x conjugate of e power j omega equal to, if you take conjugate of this, j will be replaced by minus j, a function of e power j omega minus j times be a function of e power j omega. I call this as equation 1, I call this as equation 2. Adding equation 1 and 2, equation 1 plus equation 2 gives, you add. If you add these two equations, you get x e of n will have a discrete time Fourier transform, a function of e power j omega. This implies DTFT of a real and even sequence is purely real. Equation 1 minus equation 2 gives x o of n will have a discrete time Fourier transform j into be a function of e power j omega. This implies DTFT of a real and odd signal or sequence means one and the same, is purely imaginary. Based on this property, we do a problem. Next problem. Without computing the DTFTs of the sequences given, determine the sequences having real valued DTFTs and imaginary determine the sequence having real valued DTFTs and imaginary valued DTFTs. Without computing the DTFTs of the sequences given, determine the sequences having real value DTFTs and imaginary value DTFTs. There are three problems. A. y1 of n is equal to modulus of n for n varying from minus n to plus n, 0 otherwise. Second one, y2 of n is equal to n cube for n varying from minus n to plus n, 0 otherwise. And third one, y3 of n equals 0 when n is even, 2 divided by pi n when n is odd. This problem requires the knowledge of the previous problem, first one. Since modulus of minus n is equal to modulus of n, it implies y1 of n is an even sequence. Also, y1 of n is real. Real means all the samples of y1 of n have real samples. Hence, y1 of e power j omega is purely real. Purely real means real valued. Purely real. Second one, since minus n whole cube is equal to minus n cube, it implies y2 of n is an odd sequence. is an odd sequence. Also, y2 of n is a real sequence. Is a real sequence. Real sequence means all the samples in y2 of n are real. Hence, y2 of e power j omega is purely imaginary. Is purely imaginary. I'll go to the last one. The solution of last one requires the plot of y3 of n. X-axis is n, y-axis is y3 of n. N equal to 0, 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, 3, 4, 5. Minus 5, minus 4, minus 3, minus 2, minus 1. At n equal to 0, 0, n equal to 0, 2 and 4, the samples are 0 because of y3 of n being 0 at n equal to when n is even. Similarly, at minus 2, minus 4, minus 6, the samples are 0. When n is odd, that means at n equal to 1, what is the value? When n is 1, you get the value as 2 divided by pi. When n is minus 1, you get the value minus 2 divided by pi. When n is 3, you get 2 divided by 3 pi. When n is minus 3, you get minus 2 divided by 3 pi. These two values are equal and opposite. When n is 6, you get, when n is 5, you get 2 divided by 5 pi. And when n is minus 5 here, what we get here? We get here minus 2 divided by 5 pi. At n equal to 6, it is 0. See, I will sketch y3 of n for n varying from minus 6 to plus 6. When n is 0, plus minus 2, plus minus 4, plus minus 6, the samples are 0 according to this statement. When n is odd, means 1, 3, 5, minus 1, minus 3, minus 5, the samples are correct, no, equal and opposite. These two samples are equal and opposite. These two samples are equal and opposite. These two samples are equal and opposite. What I mean by that is y3 of n is an odd sequence. All the samples in y3 of n are real. Since y3 of n is real and odd, it implies y3 of e power j omega is purely imaginary. We have done this problem without actually finding the DTFTs based on the symmetry conditions. If a function is odd and real, DTFT is purely imaginary. If a function is real and even, its DTFT is purely real. This concludes this problem.